The study of limits is an essential requirement to understanding of calculus. So in this video, we're going to define the limit of a function. We're going to give different approaches and laws that need to be applied to evaluate the limits of algebraic and some transcendental functions. And also, we're going to discuss the concept of continuity and types of discontinuity. All of these topics provide the necessary foundation that explains most concepts in differential and integral calculus. In particular, the concept of limits is important in studying rates of change in differential calculus and area of a bounded region in integral calculus. What I have mentioned are the general overview of what we are supposed to discuss the second semester in the subject Basic Calculus. And in this first video, we will focus our discussion on the following learning outcomes. You should be able to illustrate the limit of a function using table of values and the graph of a function. Also, you should be able to distinguish between the limit of f of x as x approaches c and f of c. Since this lesson aims to introduce the concept of a limit of a function as well as give its formal definition. So the discussion in this video involves using tables and graphs to evaluate limits. Hence, it would be of great importance to see how well you recall evaluating a function given its mathematical expression or graph. For that, so we are going to work on the following activities for recall and practice. So given, let f of x equals 2x plus 5. So we're going to fill in the table below by calculating the values of f using the pre-assigned values of x. Okay, so there are some pre-assigned values for x: 3, -1, 0, 2, 4, 1/2, and 0.01. Okay, so let us solve for f of x given the values for our x. So this is actually f of x. So given f of x equals 2x plus 5, so f of x equals 2x plus 5. When x is equal to 3, okay, substitute 3 for all x's. So we have 2 times 3 plus 5 equals 6 plus 5, which is equal to 11. So when x is equal to 3, our f of x is equal to 11. Okay, that's it. Then let us not erase everything. Next, when x is equal to -1, so again, substitute -1 for x, here, -1. So we have 2 times -1, we have -2 plus 5, and -2 plus 5 is equal to 3. So when x is equal to -1, our f of x is equal to 3. Okay, then let's have the next one. This time, when x equals 0, then 2 times 0 is equal to 0, then plus 5, and 0 plus 5 is equal to 5. So when x is equal to 0, our f of x is equal to 5. And let's continue. This time, our x is equal to 2. So 2 here. So 2 times 2 is equal to 4, and then plus 5 is equal to 9. So this is equal to 9. And next, we have 4. When x is equal to 4, that's it. So 2 times 4 is equal to 8, plus 5 is equal to 13. So this is actually 13. Then, next we have, let's try to erase this. We have 1/2 is equal to 2 times 1/2 plus 5. Then 2 times 1/2, we can cancel out 2. Then we have 1 plus 5 is equal to 6. So why do we have 1 here? Because 2 can be written as 2 over 1, and then times 1/2. That's it. So 2 times 1 is equal to 2, and then 1 times 2 is equal to 2. When we multiply fraction, we simply multiply numerator to numerator and denominator to denominator. So therefore, 2 divided by 2 is equal to 1. Or we can directly cancel out 2 here, and then we have 1 over 1, so therefore we have 1. And 1 plus 5 is equal to 6. So we have 6 here. Okay? And for the last one, we have 0.01. So 0.01 equals 2 times 0.01 plus 5. So 2.01, 001, I mean, 2.01 is simply equal to 0.02 plus 5 equals 5.02. So this is now 5.02. Well, actually, if the computation involves decimal numbers, we can use calculator, okay, to make our work a little bit faster. So that's it. So given the pre-assigned values for x in constructing table of values, we only need to substitute the given value for the variable and then solve for f of x. So when x equals 3, f of x equals 11. When x is equal to -1, f of x is equal to 3. And when x equals 0, f of x equals 5. When x is equal to 2, f of x equals 9. When x equals 4, f of x equals 13. And when x equals 1/2, f of x equals 6. And when x equals 0.01, f of x equals 5.02. And recall as well that when we say f of x, this is simply equal to y. Okay? So this is simply equal to y. There are some instances, or sometimes more often, that we need to plot actually the given coordinates on the Cartesian plane. So we cannot plot given f of x knowing that, if we don't know rather, that f of x is equal to y. So when we say f of x is equal to y, actually the variable here or the letter here can be changed. We could have g of x, h of x, okay, and so on and so forth, any letters from the alphabet. But usually In many books and examples, we can see f of x, g of x, h of x. Okay, so that means we're simply talking about y, or value of y. So that's it on how to construct a table of values. Next, we're going to discuss on how to determine the value of f of x or x given the graph of a function, just like in this example. Finding the value of f of x or x simply involves three simple steps. But before that, let's find out what is asked about the graph first. So question number 1, what is the value of g if x equals -5? This means that we are going to find the value of y represented by g of x. And another way of stating this question is, what is g of -5? Okay, so how do we find the value of f of x or x given the graph of a function? As I've said earlier, finding the value of f of x or x simply involves three simple steps. And the first step is we're going to find the x value on the x-axis. So in the first question earlier, what is the value of g of x if x is equal to -5? So that means we are going to mark -5 on the x-axis. And we have here the -5. And second step, we go to the graph and trace my pencil up to the graph, since the graph of the function can be found above the x-axis. So trace my pencil up to the graph here, and when I land on the graph, the third step is to go over or trace my pen over to the y-axis. So from here, we're going to go over to the y-axis, and I land on the value of 1 in the y-axis. So that means our y value, or g of -5, is 1 when x equals -5. So if we have g of -5, that means the value of our y is equal to 1. Okay? And for our second question, what is the value of g if x equals 1? So again, we apply the three simple steps involved in finding the value of f of x or x. And the first step is we're going to find the x value on the x-axis. So in the second question, we are going to mark 1 here on the x-axis. And then second step, we go to the graph and then trace my pencil up to the graph there, and when I land on the graph, my third step is to go over or trace my pen over to the y-axis, and I land on the graph on the value of 5 here in the y-axis. So that means our y value, or g of 1, is equal to 5. Okay? And for our third question, what is the value of g if x equals 3? Applying the same step or steps, we are going to find the value of g of 3. So again, we're going to find the x value on the x-axis. So in the third question, we are going to mark 3 on the x-axis, after which we go to the graph, then trace my pencil up to the graph, and when I land on the graph, third step is to go over or trace my pen to the y-axis, and I land on the value of 5 in the y-axis. So that means our y value, or g of 3, is 5. So that's quite obvious, since our graph actually is a horizontal line. So that means value of y, or we have the same value of y. For question number 2 and question number 3. And for our fourth question, at what value of x is g of x equals 0? So in question number 4, this is a little different from the 3 previous questions that we had. So in this case, the given is g of x. So that means g of x equals 0. That means the value of y is given, or y is equal to 0. And we are going to find the value of x. So in this case, we apply the same steps in finding the x value. Only that we are going to start in the y-axis instead of the x-axis. Okay? So what is, so given g of x, which is equal to 0, what is our x? So when y is equal to 0, that means the point is on, or it starts at the origin. So when y equals 0, so we are going to mark 0 on the y-axis, and we have it here. After which, when y is equal to 0, so our x is obviously equals 0. Okay, so that's it. So when y equals 0, so x is equal to 0. So again, to find the value of f of x or x, we have to apply or to follow the three simple steps involved. And the first one is we're going to find the x value on the x-axis and then mark that value on the x-axis. And second step, we go to the graph and then trace by using your pencil down or up to the graph. And then when you land on the graph, the third step, you go over or trace with your pen to the y-axis. And when you land on the value on the y-axis, so that means that is the y value for the given x value. Okay, so that is how we find the value of f of x or x given the graph of a function. Okay, so we are done with the two basic skills that we need in finding limit of a function. So that is actually by constructing a table of values or completing a table of values. And the other one is finding the value of either x or y given the graph of a function. So that means we are now ready for our main topic, which is limit of a function. But before that, to understand the concept of limits, let us consider a particular function f given by f of x equals x squared plus x minus 6 all over x minus 2. Given this function, we will investigate what happens to the values of y when we make x approach 2. So take note, when we make x approach 2. That is, when we substitute values for x which are sufficiently becoming closer and closer to 2, but not necessarily equal to 2. So, for example, there are two ways to do that. So, numbers from the left of 2 and numbers from the right of 2. We will assign values or numbers closer to 2 from the left and numbers closer to 2 from the right. It is important to note that the given function will not be defined when x equals 2. Yes, because we have here a rational function. In this case, the denominator is x minus 2. When we substitute 2 for x, we will have 0. And we know for a fact that we cannot divide by 0 because that means it makes the function meaningless or undefined. So we will not let x equals 2. So in this example, we begin with values from the left of 2. Okay? So for, let me illustrate using the number line. If this is 2, the closest number to 2 from the left is 1, right? And the closest number to 2 from the right is 3. So since we will begin with values from the left of 2, that means we will assign value or values rather greater than or equal to 1 but less than 2. So it should not be equal to 2. Since if we're going to substitute 2, it will make the function undefined or meaningless. Okay? So in this case, we will construct a table of values. We have x here, and then we have f of x. In this case, I use a vertical table of values. Okay? So when x is equal to 1, okay, so when x is equal to 1, we will find f of x when x is equal to 1. So we have f of x equals, let's substitute directly since we only have a limited space. So x squared, so that means 1 squared plus 1 minus 6 all over 1 minus 2. So let us not forget to change the value of x here as well. So we have 1, f of 1. Then 1 squared is simply 1. So 1 plus 1 minus 6 all over negative 1. And 1 plus 1 is 2 minus 6 is equal to negative 4 over negative 1. And cancel this out because negative divided by negative is positive, and 4 divided by 1 is equal to 4. So that means when x equals 1, our f of x is equal to 4. Next, let us choose another number closer to 2. Let's say 1.5. Okay, let's say 1.5. Well, actually, we can choose 1.6, but in this case, let me choose 1.5. Okay, we will observe as we assign values closer to 2, what will happen to the value of f of x. Okay, so 1.5 let me write it a little bit lower. So we have f of 1.5 equals, so 1.5 squared plus 1.5 and then minus 6. Oh. So 1.5 minus 6. Okay. All over 1.5 minus 2. Then 1.5 squared is simply equal to 2.25 plus 1.5 minus 6, and 1.5 minus 2 is simply negative 0.5. Okay, then simplify by combining 2.25 plus 1.5 minus 6. So 2.25 plus 1.5 is 375, right? Minus 6. So it's equal to negative 2.25 over negative 0.5. Then, since both the numerator and denominator are negative, so we can cancel this out. That means 2.25 divided by 0.5. So we have 2.25 divided by 0.5, and that is equal to 4.5. Okay, that's it. So when x is equal to 1.5, f of x is equal to 4.5. Oh, sorry. 4.5. Then, let's assign again value for x closer to 2. Let's erase computations here. Okay, so let's say we have 1.9. So we have 1.9. So we have f of 1.9 is equal to 1.9 squared plus 1.9 minus 6 all over 1.9 minus 2. Okay, so 1.9 squared is equal to what? So it's equal to 3.61 plus 1.9 minus 6, and 1.9 minus 2 is equal to negative 0.1. So reminder, when dealing negative signs, we should be very careful. So let us not forget to always prefix the negative sign whenever the value, or the resulting value rather, is negative. Simplifying further, we have 3.61 plus 1.9 minus 6. We have negative 0.49 over negative 0.1. Again, in this case, both the numerator and denominator are negative, so we can cancel this out. Thus, we have 0.49 divided by 0.1. So the answer is 4.9. Okay? So when x equals 1.9, f of x is equal to 4.9. Okay? Then let's assign value closer to 2 than 1.9. So let's find out. Let's say we have 1.99. Okay, let us find out what will happen to the value of f of x as the value of x gets closer and closer to 2. Take note that we are going to make x approach 2. Okay, so 1.99 is closer than 1.9. Okay, let's erase this. Since we are investigating. Okay, so 1.99. So 1.99. So 1.99 squared plus 1.99 minus 6 all over 1.99 minus 2. So 1.99 squared, that means 1.99 times 1.99. and that is equal to 3.9601, or we could have 3.96 plus 1.99 minus 6. Okay, all over 1.99 minus 2. This is equal to negative 0.01. Simplifying the numerator, we have 3.9601 plus 1.99 minus 6. We have negative 0.0499 over negative 0.01. Okay, again, since both the numerator and denominator are negative, so we can simply cancel this out. So that means negative 0.0499 divided by 0.01. So we have negative 4.99. I'm sorry, it's positive 4.99. We already canceled out the negative sign here. So we have here 4.99. Okay, that's it. Okay, then again, let's choose another value of x closer to 2 than 1.99. So let us make the right hand side. Let's add more one digit to the right hand side. Instead of 1.99, let's have 1.99. Okay, so let's add one digit here, 19. So 1.99. So 1.999 squared plus 1.999 minus 6 all over 1.999 minus 2 equals, so 1.999 squared, we have 3.96001 plus 1.999 minus 6 all over 1.999 minus 2. So we have negative 0.001. Okay, you can use calculator. Then simplifying the numerator further, we have 3.999 at 2 nines 6001 plus 1.999 minus 6. We have negative 0.00499 all over negative 0.001. So again, since both the numerator and denominator are negative, so we can directly cancel this out, and 0.00499 divided by 0.001, we have, let me write the answer directly here. So 4.99 Okay, so I think with these values, we can now observe where actually what value actually y what y value actually the number approaches to as we assign values in x closer and closer to 2, and the value actually approaches 5 if we're going to round off 4.999. Okay, so the value approaches to 5. Okay, so you might be wondering, why do we have to do this? Since the idea is to use values that are sufficiently becoming close to 2 but not equal to 2. So we initially use 1 being the integer closest to 2 from the left side, and then we will assign values more or closer to 2 or approaching to 2 from the left. Okay, that's it. So from the left, the value actually is approaching 5. Okay, when we round off the number. How about from the right? Okay, how about from the right? Before we proceed to another computations, assigning values closer to 2 from the right, let me emphasize this first. It is easy to observe that as x becomes closer and closer to 2 from the left, f becomes closer and closer to a certain value as well, particularly 5. So note that the difference of the values of f and 5 becomes smaller and smaller as the difference of the values x and 2 becomes smaller and smaller as well. Okay? So on the other hand, we also evaluate f using values to the right of 2. Okay, so let's do that. Okay, this time to the right of 2. So I've already showed earlier that the closest number to the right of 2 actually is 3. So we are going to use 3 being the integer closest to 2 from the right side. Okay, so that means x is greater than 2 but less than or equal to 3. So let's have here, and we have f of x. Oh, let's have some more spaces here on the left side. So we have f of x. That's it. So this time we will have 3. So we have f of 3 equals 3 squared plus 3 minus 6 all over 3 minus 2. So 3 squared is equal to 9 plus 3 minus 6 all over 3 minus 2 is 1. And 9 plus 3 is equal to 12 minus 6 is 6 over 1, or this is equal to 1. So when x, 6. So when x equals 3, our f of x is equal to 6. Okay? Then Earlier, the next number we assigned to for x is 1.5. This time, let's have 2.5. Okay, 2.5. So we have 2.5 squared plus 2.5 minus 6 all over 2.5 minus 2. So 2.5 squared is equal to what? 6.25. Am I right? So 2.5 squared is equal to 6.25. 6.25 plus 2.5 minus 6 all over 0.5. Then, simplifying this further, we'll have 6.25 plus 2.5 is 8.75 minus 6. We have 2.75 over 0.5. So 2.75 divided by 0.5, we have 5.5. Okay, so we have 5.5 here. Then, let's assign value a little bit smaller than 2.5. So let's have 2.1 instead. So when x is equal to 2.1, okay, 2.1. So 2.1 squared plus 2.1 minus 6 all over 2.1 minus 2 is equal to, so 2.1 squared is simply equal to 4.41 plus 2.1 minus 6 all over 0.1. Then 4.41 plus 2.1 is 6.51 minus 6. So we have 0.51 over 0.1. So 0.51 divided by 0.1 is 5.1. So this is actually 5.1. Next, let's make 2.1 smaller, okay? Or let us assign value smaller than 2.1. In this case, let's have 2.01. Okay, 2.01. Let's erase this first. Okay, so 2.01. 01. So we have 2.01 squared plus 2.01 minus 6. Oh, again. Let's move it here a little bit to the left for more spaces. We have 2.01 equals 2.01 squared plus 2.01 minus 6 all over 2.01 minus 2. So 2.01 squared is simply equal to 4.0401. Then plus 2.01 minus 6, and this is actually 0.01. 2.01 minus 2 is 0.01. Then let's simplify the numerator. 4.0401 plus 2.01 minus 6, we have 0.0501 over 0.01. So divided by 0.01. So we have 5.01. So 5.01. Okay, one more. So a little bit smaller than 2.01. We have 2.001. Okay, we have here 2.001. Hopefully the space will be enough. So we have 2.001 squared plus 2.001 minus 6 all over 2.001 minus 2. So 2.001 squared is equal to 4.004001, and then plus 2.001 minus 6 all over 0.001. So 2.001 minus 2 is 0.001. Then simplify the numerator. We have 4.004001 plus 2.001 minus 6. We have 6.005001 over 0.001. So dividing 6.005001 by 0.001 is I'm sorry. We have is it correct? Again. 4.004001 plus 2.001 minus 6 I'm sorry, this is supposed to be 0. 0.005001 divided by 0.001. Okay, so we have 5.001. Okay, so let's observe. So similarly, we can see that as x becomes closer and closer to 2, this time values from the right of 2, f becomes closer and closer to 5. The difference of the values of f and 5 becomes smaller and smaller as the difference of the values of x and 2 becomes smaller and smaller as well. So summarizing the results of the investigation for f of x equals x squared plus x minus 6 all over x minus 2, we have the following conclusions. Okay? As x approaches 2 from the left, f approaches 5. And as x approaches 2 from the right, f also approaches 5. Okay, that 5 as the limit of f of x approaches 2, which can be written as the limit of x squared plus x minus 6 all over x minus 2 as x approaches 2 is 5. Okay? So again, let me read the notation to you. So this notation is read as the limit of x squared plus x minus 6 all over x minus 2 as x approaches 2 is 5. Okay, so that's all for now. We will continue our discussion on the next video. And if you have any questions or clarifications, kindly comment it down below. And for update, please don't forget to like, subscribe, and share this video. Thank you.